So we want to talk about polar. To rectangular. So x is r cosine of theta. Y is r sine of theta. Rectangular coordinate systems are x, y. Polar is just r and theta. So if I have y is equal to 3x plus 2, how would you write this as a polar equation? No,
Oh, okay.
that's the
I thought
relationship between the two. Okay,
I
so
thought you assigned each one.
so no matter what, r is always the radius, right? R is the radius of the polar pieces. It's around the circle. Theta is the degrees. How much around the circle are you going? So the relationship between polar to rectangular is the fact that no matter what, x is equal to r cosine of theta. Why? Because cosine is x and sine is y. So it's a direct substitution between the two. It's just a direct substitution. So if I said x was 2, what would you do? Right, so all you're doing with this is just it's a direct substitution. So I have r times the sine of theta is equal to 3r cosine of theta plus 2. All right, so do you remember this trick where you have to get both r's on the same side? Not yet. So I'm going to get both those r's on the same side. So that then gives me r sine of theta minus 3r cosine of theta is equal to 2. I just need to make this a little bit smaller. I need to solve for this. So what am I going to do? Factor out the r. Then I'm left with sine of theta minus 3 cosine of theta is equal to 2. What I did there is I just factored out the greatest common factor of the r. So r is just equal to 2 over sine of theta minus 3 cosines of theta. And
the right side of the screen is
I see that, it's off. I'll have to. So again, r is the greatest common factor. So factor out r. And remember, it's because we're solving for the polar coordinates. All of that is equal to 2. So now I have my polar equation. So all I'm doing here is this now becomes r cosine theta squared plus r sine theta squared is equal to 9. Well, what is this? This is r squared cosine squared of theta plus r squared sine squared of theta is equal to 9. I still need my greatest common factor. I need to solve for r, so I take r out of both of them. Now I'm left with cosine squared of theta plus sine squared of theta is equal to 9. All of this just equals 1. So I have r squared is equal to 9, or r is equal to 3. Is you want to multiply both sides by r. The reason I want to do that, well, more than that, I need to get back to here, correct? I need to get back to our cosine theta. I don't have that right now. Right now I have 2. I need the variable r inside there in order for me to pull the x out. So as soon as I have that, now I can go ahead and say r squared is equal to negative 2 r cosine of theta. All right, r squared becomes x squared plus y squared. R cosine of theta becomes negative 2 x, right? We have to complete the squares. We move the 2x over. So then I have x squared plus 2x plus y squared is equal to 0. So I need to put it back in the form of a circle. So I need to turn that into a perfect square. With a perfect square, what we end up doing is you take whatever this value is, 2 divided by 2, and then square it. So that gives me what? I add 1 here and 1 there. This is my perfect square of x plus 1 squared plus y squared is equal to 1. Again, what does x equal? R cosine theta. Y is equal to r sine of theta. Now, when I plug that in, I don't want just x or y. Wrote the wrong thing. I want r cosine of theta. What do you think y squared actually equals? Is it? Yeah, it's exactly what you think. It's r squared sine squared of theta. All right, so the trick we used last time was multiplying both sides by r, right? So what am I going to do this time? I have an equation. So I want an equation the same way I want, so I can multiply it or divide both sides by r. So I'm left with cosine of theta is equal to r sine squared of theta so r is cosine of theta over sine squared of theta. But I can write that differently if I wanted to, right? Could I write that as the cosine of theta over the sine of theta times 1 over the sine of theta? Yeah. It's usually how they want it. So really r is equal to cotangent of theta and the cosecant of theta. you can pick any parameter you want. Or need, more likely, right? The parameter that you need to go ahead and describe something in physics and all of that, you have to pick which will work for your equations. So let's say,
What is that?
now, the only thing that you have to be careful of is all values of the original domain must still be included. That's the biggest piece. 9 minus x squared. So instead of saying x squared, I write it as, yep. So we don't want to use y anymore. Now we want to change that to f of t is equal to 9 minus t to the third squared. I did it again. I was on the wrong side. Sorry. So that would be f of t is equal to 9 minus t to the third squared. Or just 9 minus t to the 6th power. All right, again, like I said, just think about this as substitution. So this is 9 minus t plus 1 squared